So similarly, in acids and bases also you have dilute and concentrated acids and bases. Now acids, as we know, they are in solutions they are the acid and the water. So here water is the solvent and acid is the solute or base in case of bases. So when you have a fixed quantity of water and you add a little bit of acid to it, so it is a very dilute solution because there is very less solute and there is lots of solvent. But you keep adding acid to the water and the concentration of the acid or the quantity of acid will increase. As the quantity of acid increases, the relative, acid will become a quantity comparable to the water, and as you increase the quantity of acid, the solution which was earlier dilute will now go towards concentrated. And a very important thing which is very frequently asked is that while diluting, should we add water to acid or acid to water? This is a question very frequently asked. So if we add water to acid, you have acid over here and you start adding water. Now the acid and water, they do react and form this, the acid dissociates. So the acid and the water, they will react, and this reaction is highly exothermic. Exothermic means it will release energy, and energy in the form of heat in this case. So when you add water, this energy, the reaction will take place, and since the reaction is highly exothermic, a large amount of energy will be released, and this energy will be released in the form of heat. And so you have water over here and you add it here, and the reaction will take place somewhere here. So here this huge amount of heat will be generated, and this beaker which is made of glass, this may get cracked due to heat. So, and if the beaker gets cracked, the acid will fall down and it may damage, or it is very dangerous because this acid is concentrated. You are diluting it. This acid, you have taken a concentrated acid. So adding water to acid is definitely not the way of diluting the acid. Now if we had water over here and we add acid to it, so now what will happen is that the reaction will still take place, the acid, when you add, the reaction will take place, and since it is highly exothermic, it will release a lot of energy. But this water is a very good absorber of heat. So, and water, it has the property that it absorbs a lot of heat and its temperature increases very little. So water will absorb all the heat or all the energy which is generated during the reaction, or most of the heat, and so the beaker will remain safe. So in this case, adding acid to water is the better option to dilute the acid. In case of water to acid, the reaction takes place inside the acid, and acid is itself a heating medium, so it will obviously not absorb heat. But in acid to water, the reaction takes place in water, and water will absorb the heat which is produced. So the answer is that acid to water should be performed, and that too very slowly, drop by drop, and with constant stirring. Because if you don't add drop by drop, if you just pour the acid inside the water, then the heat generated will be too large, and even water will not be able to absorb the heat. So drop by drop you should add, so that the heat generated is less, and the constant stirring will actually, it will spread the heat all over the water. The stirring will spread the energy all over the water. So it should be acid to water, slowly, drop by drop, and with constant stirring. So that is the procedure of diluting an acid. Now we come to another very important and very interesting topic, which is I should write it like this: the pH of substances. Now, I had already told a bit about pH, that pH for acids is less than 7, pH for salts is equal to 7, pH for bases is greater than 7. All that was not understood then. So now we are going to study this concept of pH. So pH, it means potential of hydrogen. It is basically a measure of the strength of acids or bases. This pH, and how does it measure the strength of acids or bases? It takes into account the concentration of H plus ions in the solution. Now you might be thinking that if there are at all H plus ions in the solution, it must be an acid. How can it be a base? But that is again a wrong concept. Bases will also contain H plus ions. But the concentration or the number of H plus ions is very less compared to concentration or number of OH minus ions. You know, water also dissociates into H plus and OH minus ions, but it is a very weak electrolyte, so it will not dissociate completely into this H plus and OH minus ion. That means if you have, suppose, 1 liter of water, in that very few milliliters of H plus and OH minus ions will be formed. If you have suppose 1 kg of water, then maybe 1 gram of H plus ions will be formed. So this H plus and OH minus ions are formed due to the dissociation of this water, but the OH minus ions which are present in the base are formed due to dissociation of the base. So the bases are very good electrolytes, they will dissociate completely. So this OH minus, this will be very high in number, and there will be some OH minus from H2O also that will be added, but that is just negligible because compared to this concentration is very less. And there will also be H plus ions from the water. So this H plus ions are also present in bases, but their number is so less that we can just ignore them. We can just take it to be OH minus. Similarly, acids like HCl will also dissociate into H plus and Cl minus. Now, in this case, this H plus, the number of H plus will be very high, and this is also an extra amount of H plus, but this can be neglected because it is so less. But this OH minus ions, although very less in number, are also present. So an acid contains H plus ions in very large number, but it also contains OH minus ions, though they are very less in number. So we have bases, and make this clear that bases will also contain H plus ions other than OH minus ions, but the H plus ions will be very less in number, and acids will contain OH minus ions other than H plus, but this concentration of OH minus will be much less, very less.